Alright, let's start with something that's at the core of manufacturing efficiency, OEE, or overall equipment effectiveness. So when we talk about OEE, we are talking about how effectively a piece of equipment is being used during production time. In simple terms, it's a measure of how close you are to perfect manufacturing. If your OEE is 100%, that means you are producing only good parts as fast as possible with zero downtime. And of course, in the real world, that's rare, but it gives us a goalpost, something to aim for. Okay, now here's a key formula that ties everything together. OEE equals availability times performance times equality. Now, this formula is not just math on paper. It represents three different aspects of your production. Availability tells us how often your equipment is actually running when it's supposed to. Performance measures how fast it's running compared to its ideal speed. And quality, that's about how many parts you produce that meet your standards without needing rework or getting scrapped. So when you multiply all three, you get a single number that sums up how well your process is running overall. And okay, OEE didn't just appear out of nowhere. It was first developed in Japan as part of a system called Total Productive Maintenance, or TPM for short. The idea was simple: involve everyone from operators to managers in keeping equipment reliable and productive. Over time, OEE became an international standard for measuring how effective a production system really is. And what makes it valuable is its consistency. You can compare OEE across different machines, lines, or even entire factories and see where things are performing well or where you're losing efficiency. Okay, now let's talk about why OEE matters so much in practice. Every single percentage point increase in OEE translates directly into more output without spending extra money on new equipment. Think about that. If you raise your OEE from 60% to 85%, you have effectively increased your capacity by about 42%. Okay, and that's without adding a single new machine. So improving OEE is like finding extra production power hidden in your existing resources. And here, another angle, competition. World-class manufacturers tend to achieve OEE scores around 85% or higher. When you operate at that level, you can produce faster, lower your costs, and keep your product quality consistent. So, in markets where speed and reliability matter, your OEE score becomes a real differentiator. If your competitors are running at 60% and you are hitting 85%, you are simply more efficient in everything you do, from meeting deadlines to managing expenses. And on the other hand, OEE is not just about improving output, it also gives managers and engineers a clear view of what's actually happening on the shop floor. Instead of relying on guesses, you get hard data showing where time is lost and where performance drops. That data becomes the foundation for decision making. Whether it's scheduling maintenance, adjusting staffing, or redesigning workflows, OEE helps everyone align around the same performance goal. Okay, here industry benchmarks, and we can continue. Alright. Yes. Look at this. New page. Okay. Let's break down those three components in more detail, starting with availability. What are they? Let's look at this. Availability measures how much your plant production time was actually spent producing, and the formula is here, you can see. So If your equipment was supposed to run for 8 hours, but due to changeovers, breakdowns, or meetings, it only ran for 7, your availability would be 7 divided by 8, or about 87.5%. And availability losses usually come from unplanned stops, like equipment failures, or planned ones, like maintenance and setup. Okay, and here, performance. This one looks at how efficiently your machine runs compared to its maximum design speed. The formula here is here. Performance equals idle cycle time times total count divided by operating time. And let's say your machine can ideally produce one part every minute, but it's running slower because of small stops or slow cycles. And those delays reduce your performance percentage. Even minor slowdowns can drag your numbers down, so monitoring performance helps catch those inefficiencies early. Okay, quality here. Quality measures how many of the total parts produced are actually good, and the formula goes like this. Quality equals good count divided by total count. If you made 340 parts but only 320 passed inspection, your quality rate would be about 94%. So defects, rework, or scrap all of these lower your quality score. And by tracking this, you can pinpoint recurring issues and reduce waste in your process. Alright, that page is done, and calculation part. Okay, now we will pull all of this together in a practical example. And let's see what's happening here. Let's say we are working with an injection molding machine. The shift lasts 8 hours or 480 minutes. Out of that, 40 minutes are planned downtime for breaks or meetings. That leaves us with a planned production time of 440 minutes. But then the machine loses another 60 minutes to changeovers and breakdowns, which brings our operating time down to 380 minutes. So using our formula, availability equals 380 divided by 440, which gives us 86.4%. Okay, and then if the ideal cycle time is 1 minute per part and we produce 340 parts, our performance becomes 1 times 340 divided by 380, which equals 89.5%. Okay, if the 20 parts were defective, and what's happening? Look at this. That means we had 320 good parts out of 340 total, giving a quality score of 94.1%. Multiply all three, 0.864 times, 0.895 times, 0.941, and we get a total OEE of about 72.8%. Okay, so while each individual component looks decent, the combined effect shows there's plenty of room to improve. Of course, you can see that. That's the key takeaway. Small inefficiencies across availability, performance, and quality add up fast, and that's why OEE helps you see the full picture. Okay, inside here. Okay, let's continue. Click. Here we have an interactive part. So here our availability, performance, and quality scores, and here we have a bar chart. And let's change quality and let's change performance here. Was changing performance and OEE, okay, and okay, yes, 90 is good. And availability, look at this, and OEE, I'm changing now. OEE is good now, okay, and our card's current OEE classification potential gain is here, and that was good, but let's decrease. Now it is low. Okay, and our losses is here. Look at this. Now we will talk about something really important for improving OE, the 6 big losses. These losses come from a framework that was developed as part of Total Productive Maintenance or TPM. The idea here is that most manufacturing inefficiencies can be grouped into 6 main categories, and understanding these losses helps us identify where time and performance are slipping away. On the screen, you can see a pie chart showing their typical distribution across a manufacturing facility. Equipment failures take up about 28%, setup and adjustments around 18%, minor stops 15%, reduced speed 16%, startup defects 10%, and production defects 13%. Okay, so if you want to systematically improve OE, this is where you start, by recognizing which of these 6 areas is eating up most of your productivity. And okay, let's look at this. The first one here, equipment failures or breakdowns. This is usually the most visible costly. These are unplanned stops caused by things like worn parts, poor lubrication, operator mistakes, or design flaws. In most plants, equipment failures account for about 5 to 20% of total production time. The main focus for improvement here is prevention, and regular maintenance, proper training, and condition monitoring can reduce these breakdowns dramatically. So, instead of waiting for machines to fail, you get ahead of the problem with preventive or predictive maintenance. Okay, and setup and adjustments. The second loss type under availability is setup and adjustments, and this includes the time you spend changing from one product to another, setup, warm up, calibration, or fine-tuning the machine. Even though these are planned activities, they often take longer than expected in real life, and typically setup and adjustment losses consume to 2%, 2 to 10% of production. Okay, and the solution, what is that? Techniques like SMAT, what is that? Single minute exchange of die. What is that? It is a method that helps reduce setup time by standardizing the process, preparing tools and materials in advance, and simplifying steps. And we will look at this technique after. Next, we move into performance losses, another important topic. The first one here is idling at minor stops. These are those small interruptions like a material jam, a misfit, or a sensor problem that don't qualify as full breakdowns but still reduce throughput. Because they are short and frequent, they often go unrecorded and underestimated. They can take away around 3 to 10% of production time. And to minimize this, good workplace organization, preventive maintenance, and small automation improvements make a big difference. Alright, 4. Reduce speed. This happens when machines run slower than their designed or theoretical cycle time. Causes can range from worn-out components and poor process parameters to operator fatigue or intentional slowdowns to avoid quality issues. The loss here usually accounts for 5 to 15% of total capacity. To fix this, you can look into process optimization, upgrading equipment, or fine-tuning your settings. And training operators to recognize and correct speed variations also plays a key role. Alright, 5 and quality losses. Here we will look at startup rejects. What are they? Or startup defects. These are defective parts produced right after a machine starts up, during warm-up, or immediately following a changeover. Essentially, the process is not fully stable yet. Typically, these defects account for 1 to 5% of production, and the goal is to reach steady-state production faster. Standardizing your startup procedures using better changeover methods and automating parameter controls helps stabilize the process sooner and reduce waste. Okay, and here production rejects. Look at this. These are defective parts made during normal operation, scrap, rework, or any product that doesn't meet quality requirements. This usually accounts for 1 to 10% of production, and the key here is controlling the process so defects don't happen in the first place. Tools like Pocoyoke, which means error proofing, along with operator training and statistical process control, are highly effective in preventing these issues. Now, if you look at the bigger picture, in a typical manufacturing facility, available losses make up roughly 40% of total OEE losses. Performance losses account for about 35% and quality losses around 25%. Of course, this varies depending on the industry and production type. But what matters is measuring and prioritizing. You can't fix everything at once, so start with the largest contributors to loss and eliminate them one by one. Everything takes time. Okay, this is done, and let's look at systematic improvement strategies. Alright, so how do you actually improve OEE in a structured way? It starts with measurements. Step 1 is establishing a baseline, collecting accurate data on downtime, cycle times, and quality issues. Even manual tracking is fine at first, but automated data capture gives you a much clearer view. Step 2 is performing a Pareto analysis of losses. Usually 20% of the loss categories cause 80% of 80% of the inefficiency. So you focus your efforts there. Step 3 is root cause analysis. Here, you dig into why those losses happen using tools like the 5 whys or fishbone diagrams. The goal is not to fix the symptoms, it's to fix the real cause. Okay, and once you know the causes, step 4 is to implement countermeasures. These are targeted actions that directly address root causes, like improving a maintenance schedule, redesigning a setup, or adjusting a process parameter. Step 5 is monitoring and verifying the results. You need to make sure improvements actually last. Use trend charts or control charts to check if things stay stable over time. And finally, step 6 is continuous improvement. This is not a one-time task. It's an ongoing cycle. Regular reviews, progressive targets, and a culture where everyone contributes ideas keep the process alive. And that's how you turn OE improvement from a project into a habit. Let's start by talking about how OEE benchmarks vary across industries. Not every factory has the same conditions, right? So, for example, semiconductor manufacturing typically operates at around 82% OEE. Let me show you. Okay, aiming for a world-class target of 90%. That's because they have highly automated, tightly controlled processes where downtime or defects are incredibly costly. On the other hand, packaging or discrete manufacturing sits lower, around 60 to 67% on average. Their targets are closer to 75 to 82%. The key takeaway here is that context matters. A world-class OE for one industry might be just average for another. So when you're setting goals, always compare your numbers to realistic industry benchmarks, not same universal magic number. Okay, and here, what's happening? We will zoom in on discrete manufacturing. This includes industries like automotive, electronics, and machinery. These operations deal with frequent product changeovers, multiple variants, and complex assembly lines. Because of that, their OE tends to fall between 60 and 75%. The main improvement opportunities here revolve around setup reduction, improving quality at the source, and balancing production lines to minimize idle time. If you are in this sector, your best wins usually come from optimizing changeovers using SMATs and ensuring operators have clear, standardized work instructions to keep things consistent. Moving to process manufacturing, think chemicals or food and beverage or other things. These industries have long, continuous runs and extremely tight quality controls. Typical OE ranges between 70 and 85%. And since unplanned downtime can disrupt entire batches and cost millions, focus areas here include reducing equipment failures, fine-tuning process parameters, and minimizing batch losses. Predictive maintenance and real-time process monitoring make a huge difference here. Essentially, consistency and control are the name of the game. Okay, semiconductor fabrication. This one's the elite club of manufacturing efficiency. OE here can reach between 75 and 90% thanks to advanced automation and precision. These facilities produce high-value components with extremely long cycle times and no room for contamination. So their focus is on preventive maintenance, contamination control, and maximizing yield through process optimization. Every wafer counts, and even a small improvement in yield can translate into huge gains. And packaging operations here. This area usually has OE between 55 and 70%, which might seem lower, but it makes sense. Why? Packaging lines handle high speeds, frequent product switches, and a wide variety of CQs. The main culprits of loss here are minor stops, quick changeovers, and material handling inefficiencies. The best strategies include improving first-pass quality, fine-tuning changeover procedures, and maintaining steady flow through good scheduling and material supply discipline. Okay, now that we understand the industry differences, let's look at how to actually implement OE improvement. And phase 1 is what we call the foundation phase. Usually the first 1 to 3 months. This is all about getting the basics right. You install data collection systems, train your operators on OE concepts, and establish baseline measurements. You also identify the biggest loss categories and form cross-functional improvement teams. The goal is not to fix everything immediately, it's to build awareness, gather accurate data, and create a structure for continuous improvement. Okay, phase 2 covering months 4 to 6 is about achieving quick wins. Here is where you go after the low-hanging fruit that delivers visible results fast. You roll out 5S and visual management to clean up and stabilize operations. You standardize changeover procedures and tackle obvious maintenance problems. So the idea is to build momentum, show people that improvement is possible, boost engagement, and start embedding problem-solving habits among operators. Then comes phase 3, here, systematic improvement. Typically months 7 to 12. At this point, you start deploying advanced techniques like CMAC, TPM, and predictive maintenance. You optimize process parameters and develop standardized work procedures for every operation. Quality control systems are formalized and data-driven decision-making becomes the norm. Basically, you shift from reactive firefighting to proactive management. The final phase, called continuous excellence, is ongoing. It never really ends. Here, the goal is world-class performance. You benchmark against the best in your industry, leverage AI and advanced analytics, and expand successful methods across the entire facility. But remember, those alone don't make the difference. The real success factors are leadership, commitment, operator engagement, reliable data, and structured problem solving. Improving OEE is not a sprint, it is a marathon that requires discipline, patience, and a culture that rewards continuous learning. And here success factors. Okay, final page, and here advanced OEE concepts. Okay, now let's dive into the advanced stuff, starting with TEEP. What is that? Which stands for Total Effective Equipment Performance. The formula is simple, as you can see here. TEEP equals OE multiplied by utilization. What makes TEEP special is that it measures effectiveness against total calendar time, not just scheduled time. I mean, in other words, it tells you how well you are using your equipment when you factor in all available hours in a week or month. This metric is especially important for capital-intensive operations like semiconductor fabs or refineries, where maximizing utilization directly affects profitability. And here we will look at the oil loss waterfall analysis, and this visualization helps you see how ideal production capacity gradually drops down through various through various types of losses until you reach your actual output. And let's say starting at 100% capacity, then you lose 12% to availability issues, 9% to performance losses, and another 7% to quality problems. What you are left with is 72% actual output, and this kind of chart is incredibly powerful because it visually communicates where your biggest gaps are and helps everyone, from operators to executives, align on which losses to prioritize first. Okay, and other advanced things. Let's start by talking about how real-time oil monitoring has changed the game. And with modern digital manufacturing execution systems, or MES, companies now have the ability to see exactly what's happening on the shop floor at any given second. These platforms give operators instant feedback, so if something goes wrong, they can act immediately instead of waiting or for reports later. Supervisors can jump in proactively to prevent losses before they snowball, and management gets a full enterprise-wide view of performance. And here we can say it's about connecting every level of the organization in real time, creating a faster, smarter, and more responsive operation. Predictive analytics is here, and here let's say being able to spot a potential equipment failure before it actually happens. That's what predictive analytics enables. By analyzing historical OE data with machine learning, we can identify subtle warning signs like temperature fluctuations, vibration anomalies, or performance drifts long before a breakdown occurs. And this allows maintenance teams to act strategically, scheduling interventions when they are least disruptive. And it's a complete shift in mindset from reactive firefighting to predictive management. So the result, higher uptime, fewer surprises, and a production environment that runs with confidence instead of chaos. Okay, Industry 4.0, another important. Now we move into the world of Industry 4.0. This is where OE meets smart technology. IoT sensors capture every little movement, every downtime event, every variation in speed or quality. Edge computing processes that data instantly right where it is generated, enabling real-time decisions. Then digital twins come into play, virtual models of your machines that let you simulate different improvement scenarios before touching the real system. And artificial intelligence ties it all together, autonomously optimizing production parameters. So instead of reacting to issues, the system learns from itself, adjusts automatically, and continuously drives efficiency. That's the power of Industry 4.0. It turns OE from a report into a living, breathing intelligence engine. Okay, and here some feature things, and here some common pitfalls to avoid, and there are common mistakes we must avoid. The first one is focusing too much on the OE number itself. People often get obsessed with hitting a percentage, but OE is not the finish line, it's a diagnostic tool. And the real purpose of OE is to help you uncover where and why you are losing effectiveness. If you chase a number without addressing root causes, you might end up with impressive results, but little actual improvements. Always remember, OE tells you the story, but you still have to interpret it and act on it. And the second big mistake is inconsistent measurement. You can't track improvement if the definition of downtime or good output keeps changing every few months. It's like trying to measure growth with a ruler that keeps shrinking. Consistency in your metrics, methods, and standards is what makes trend analysis meaningful. That's why it is so important to establish clear definitions and stick to them across shifts, lines, and plants. Everyone must speak the same language when it comes to OEE. And here, 3. There is a simple truth here. Garbage in, garbage out. If the data feeding your OE system is incomplete, delayed, or inaccurate, your conclusions will be flawed and your decisions will suffer. That's why investing in accurate data collection and validation is non-negotiable. Automated systems usually outperform manual tracking because they remove human error and provide continuous accuracy. When your data is clean, your insights are trustworthy, and that's when OE becomes truly powerful. And It is another important topic, and I value that. Here, operators are the ones who live with the machines every day. They know the subtle noises, vibrations, and quirks that no sensor can detect. If you leave them out of the process, you are throwing away a gold mine of information. Engage them in problem solving, encourage their feedback, and make them part of improvement discussions. Not only does this boost morale, but it also leads to smarter, faster, and more grounded solutions. Yes, and final part of this lesson, the last one ties everything together. Short-term thinking. OE improvement is not about quick fixes or overnight gains. It's a cultural transformation that takes time, consistency, and leadership commitment. And if you treat it like a one-off project, results will fade just as quickly as they appear. Sustainable OE improvement means embedding it into your daily operations, training your people, and nurturing a mindset of continuous growth. In other words, it is not a sprint, it's a marathon that rewards those who stay the course.